So we're now going to continue on with our overview of the key methods that are part of the Java Executor Service. You'll see here that these methods are going to be used to manage the lifecycle of the Executor Service, which also, of course, will indirectly affect the lifecycle of the tasks that are running concurrently in the Executor Service as well. So we talked before about how tasks in the Executor Service can be in one of four states. It turns out that the Executor Service itself can also be in different states. In fact, one of three states. And these three states are shown here. They could be running, shutting down, or terminated. So let's talk about these states. So after you've created an instance of an Executor Service, for example, by saying executors.new fixed thread pool or executors.new cache thread pool or whatever, then the Executor Service will be in the running state. After the shutdown method is called, there's a couple different shutdown methods, and you can either shut things down gracefully or abruptly. Then the Executor Service will be in the shutting down state. So it's in the process of shutting down, if shutdown or shutdown now is called. And then finally, after all the tasks that were running have terminated, then the Executor Service will be in the terminated state. And it's important to know the different states and what happens when the different states are in effect, because the behavior of different method calls on Executor Service interface or through the Executor Service interface will vary depending on the state it's in. So let's go ahead and talk about some of the methods that influence the state that the Executor Service can be in. So we'll start first by talking about how to shut down the Executor Service. So assuming that the Executor Service is actually running because you created a new thread pool of some type that is used to implement the Executor Service, then we have a pair of methods that can control how it gets shut down. The shutdown method performs what's called a graceful shutdown, and that's used to essentially allow actively running tasks to complete. However, if you try to submit or execute new tasks, then those tasks will be ignored. So they're not going to be processed. They're just going to be dropped or not even run at all. And tasks that are waiting to run but not actually active will also be ignored too. Conversely, the shutdown now method is more draconian. So what it will do is it will actually go out and attempt to cancel active tasks by interrupting them. And of course, it also doesn't process any waiting tasks, and it ignores any new tasks that are submitted as well. So it's a bit more it's a bit more forceful in what it tries to do. The way that tasks that are running are canceled is by posting something called an interrupt request to the threads that are running. And this, of course, is all done behind the scenes by the Executor Service implementation. So this is typically done by whatever thread pool is being used to implement that interface. And we'll talk later in more detail about how you can interrupt threads and cancel threads and so on. But the thing to remember is that canceling threads or canceling tasks is always voluntary in Java. There's no portable, acceptable way of abruptly shutting down threads. So even when you do shutdown now, it still relies on voluntary cooperation on the part of the running threads to shut themselves down. And that requires some collaboration between different parts of the Java executor framework and any code that you might write to implement the run or call methods in runnables and callables. So always remember that. We'll talk about this in more detail later, but the thing to remember is that threads don't get shut down arbitrarily and unilaterally. They have to participate in their own demise, if you will. The shutdown now method will return the tasks that are waiting to run but not currently active. And you might need those if you want to know what didn't start, for example. So you get back to the call or all the threads that are all the tasks that haven't had a chance to run yet. I don't normally do anything with this, but it does give it back to you in case you need to do something with it. If you try to submit a task to the Executor Service after it's been shut down, then something called the rejected exception handler takes effect and will decide what to do. And the rejected exception handler can either decide to silently discard any submitted tasks, just say, oh, well, it's shutting down, I'm just going to ignore them altogether. Or it can decide to throw the rejected exception, rejected execution exception. So when you try to submit or execute a task and you've turned on that feature, then you're going to get back in some mode the rejected execution exception. And that could be a good way of knowing, you did something wrong. Whereas just simply failing silently won't cause an exception to be thrown, but it might also lead you to believe that your call to execute or submit actually worked when it didn't. Now, once an instance of an executor service has been shut down, then you can query to find out what its current state is. And this can be useful for a variety of reasons we'll talk about as we discuss these methods. And there's basically 3 methods you can use to do things on executor service instances to see whether or not they've been shut down or canceled. So, of course, there's a method that's called isShutDown, which will refer and return what state you're in. And if you're in the shutdown state, then that will return true because it's a Boolean. Likewise, if the executor service implementation is in fact terminated, then the isTerminated method will return true. So if it's in the terminated state, that'll return true. And then finally, there's a method that can be used for barrier synchronization called await termination. And this can be used to block until all the tasks that are currently active have stopped running, and the executor service at that point will be considered terminated. So basically, it's a way of waiting for that to happen. And one reason for preferring to use shutdown now rather than using shutdown is that you may get faster termination with shutdown now, so that await termination won't have to wait as long, because doing shutdown, which is graceful, which is polite, will let the actively running tasks continue. And if they continue to run for a while, you may have to wait a while, getting more and more impatient for the executor service to actually be done. So if you do shutdown now, then the response may return faster and you may terminate quicker because you'll actively go out and try to shut those tasks down. You can think of the various shutdown methods when used in conjunction with await termination as performing a variant of a barrier synchronizer. We'll talk more about barrier synchronizers later in this class, and there's a bunch of really powerful ones, but this can be used in a fairly straightforward way, in much the same way that the thread join method on a thread can also be used as a barrier. Basically, the barrier there is waiting for the thread to finish its execution. So await termination is kind of like join, except now you're waiting for all the threads to finish their computations after you've shut down the executor service. So that's the end of the second group of methods that are part of the executor service interface. So part 1 talked about the methods for submitting tasks to be processed, either one at a time through execute or submit, or in batches using invoke all or invoke any. And now we talked about some of the methods that can be used to control the life cycle of the executor service itself. And also be aware that these methods can also control the life cycle of the tasks that are running, because if you do a shutdown now, of course, those tasks will be asked to terminate themselves as quickly as possible.